So there's not a lot to do on the front because it is just basically a lesson to show us. So I do want you to think about it and listen to what we're saying. To find the probability of multiple events, you must find the probability of each event and then multiply them together. So we are going to be rolling 2 die. That means we have 36 outcomes, right? There's 6 outcomes on the first die times 6 outcomes on the second one. So that'd be 36 outcomes. We multiply all possible outcomes together. Now, we said on here, what is the probability of rolling a 6, then a 5? Now, does the probability of the second roll change because what roll the first time? When I roll a die, there's 6 sides on it, right? And when I roll it again, are there still 6 sides that I can get? Yes. So the probability involves independent events. One event does not change the other event. The first roll does not affect the second roll's outcome. So the probability of rolling a 6 on the first roll is 1 out of 6. Then the probability of rolling a 5 is 1 out of 6. So I'm not trying to do this all together. I'm looking at each event, the probability of rolling a 6, the probability of rolling a 5, and then we multiply them together. The idea is the word and means you're going to multiply them together. When you see and, it means multiply. Now, it doesn't say and in here, but think about this. What's the probability of rolling a 6 and then rolling a 5? So the idea is you want a 6 and you want a 5. So we take the probability of 1 6 times 1 6, 1 times 1. There's only one way to get a 5 or a 6 and a 5 out of 36 total outcomes. All right, so 136 is the probability of it happening. Now, we have in a second example, and it says, what's the probability of drawing 5 hearts from a deck of cards without replacing them? Okay, so you draw a card and you keep it. So every time you pick a card, there are less cards in the deck. Agreed? Now, the probability involves dependent events because the first event changes everything else. Drawing a card and not replacing it affects the probability of the next card. So the first heart, you have 13 hearts out of 52. That's one of the suits. Then the second heart, there are 12 out of 51. Notice, and here's what you have to do. Whenever you're saying you want to draw 5 hearts, you have to assume that what you wanted happened. So we assume the first card we got was a heart. So there's one less card of hearts and one less overall card. Then you drew a second card. It has to be a heart. Now there's only 11 out of 50. Draw another heart, 10 out of 49. Draw another one, 9 out of 48. So you take all of these probabilities and you multiply them together. So the reason this is changing is because you're drawing a card and you're keeping it. Now, if the first card you get's not a heart, then the whole thing's thrown out. So when we're looking for probability, we assume the event happens each time. So I would just take my calculator and type these in and get your final answer. They're showing here how you can sort of reduce each fraction. I'm fine with either, but at this point, I'm okay plugging them in. Final answer is 33 out of 16,660. So it's unlikely that you're going to draw 5 hearts in a row. All right, so let's talk about some problems on the back here. So it's going to say you try, but we're going to try some of these together. First thing we need to determine, is this going to be dependent or independent? So what's the probability of drawing a queen from a deck of cards, replacing it, and then drawing a diamond? If the card is being replaced, does it affect the second card pick? No. So this would be considered independent, and that is important for us to understand. So this is an independent event. Please write that down. And why is it independent? Because you are replacing the card, so it's not changing the outcome. Okay, now, what's the probability of drawing a queen? All right, how many queens are in my deck of cards?
4.
4 queens out of how many?
53.
52 cards in a deck. And we're going to put it back, so we have all 52 cards, and then we want to draw a diamond. How many diamond cards are there?
10.
There are 13. Yeah, 13 diamonds. And what do we do with our 2 probabilities? We multiply them. So the probability of getting a queen was 4 out of 52. The probability of getting a diamond was 13 out of 52. And then I'm just going to type it in my calculator. 4 50 seconds times 13 over 52. And 1 over 52, I agree with you. And as long as you have a reduced fraction, that is good. You could give it as a decimal if you want. All right. What is the probability of rolling a 6 and then rolling an even number? All right, how many ways can I roll a 6?
6 is an even number.
Okay, so we have to talk about that. Hey,
2 and 3.
dependent or independent here?
Dependent.
When I roll independent because the rolls don't affect each other. Okay. What's the probability of rolling a 6? 1 out of 6. What's the probability of rolling an even number?
3 out of 6.
Okay, but here's the issue. If you think about rolling a die, 1, 2, 3, 4, 5, and a 6, there is only one way to roll a 6. But when we say how many ways can you roll an even number, that's a 2, a 4, or a 6. Is it okay that we're double counting the 6? Yes, because it's not an or statement. So don't get that mixed up. The probability of rolling a 6 is 1/6. The probability of rolling an even is 3 out of 6. If it said rolling a 6 or an even number, then we can't double count. So I'm going to take my 1/6 times 3/6. You can throw that in the calculator. It's 3 over 36, which reduces to what?
1 over 12.
1 over 12. Okay, look at number 3. What is the probability of drawing 3 diamonds from a deck of cards without replacing them? So you're not replacing it. You told me it's what? Dependent. So the first card pick, I want to get a diamond. Okay, well, how many diamonds are there in my deck? There are 13 diamonds. So there are 13 diamonds out of 52. That's my first one. I keep the diamond. How many diamonds are left in the deck?
12.
How many cards are left in the deck? Do you understand that idea? We got a diamond, so now there's one less diamond and one less card. Okay, I keep the second diamond, and I'm going for my third one. How many diamonds are in the deck? Now there's only 11 out of 50. Okay, I'm going to use my calculator for this. Now, if you really wanted to, you could just multiply the top, then the bottom. I'm going to let the calculator just do fractions. And see if you guys agree with me. I'm getting 11 out of 850.
That's what I've got too.
Okay. My calculator will reduce it. If you have a calculator that you need to hit the key to simplify it, make sure you do that. Okay. So I'm going to have you try the rest, but let's just talk about this real quick. This is your diagram. How many, I think these are checkers, they said, not marbles, but checkers. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Someone double check. I counted 14
Of what?
of all these checkers. So there's a total of 14. And then you could write out how many of each there are, but I think you can see it fine. It says, what's the probability of drawing a black checker and a white checker without replacement? So is that dependent or independent? It is dependent.
I think it's 15.
Oh, it's 15?
Yeah,
Oh, yeah, I missed one.
when I broke it down.
1, 2, 3, 4, 5.
White, 6,
Oh, there's like 5.
gray.
Well, there's rows of 3, and I just.
Well, and I just looked at the rows of 5. Okay, good catch, because everything would have been wrong then. All right, so it's out of 15. Okay, so if you're thinking, I want to do one more of these because this one's a little bit different. What's the probability of getting a black checker? How many black checkers are there?
6.
All right, I agree with your 6 out of 15. So the probability of getting a black is 6 out of 15, but you don't put them back, right? You're going to take, well, how many? And then we want to get a white checker. How many white checkers are there?
4 out of 14.
Okay, so when you say you're taking one out, it's still 14. So you assume there are 6 chances out of 15 to get a black checker. You assume you got one black checker. That doesn't affect the white checkers, but you do have only 14. Do you see what you did there? So if you're getting the same card, then you lose a diamond and an overall card. Here, we took out a black checker, so we still had 4 white checkers, but we only had 14. Okay, what's this end up being? You're going to have to reduce it.
4/35.
Yep, I agree with you. 4/35. Now, having all these different denominators, 4/35 doesn't mean a lot to me. So if I was trying to compare if this probability is more likely than something else, I would take that 4 divided by 35 and I'd look at the decimal. And that helps me to see how close it is to 0 or 1. Okay, so go ahead and work on these.